How about this time? Can you guys hear me? Can you guys hear me for this time? No sound. Let me have a look. Okay. Yes. So now let's go to the pigeonholes here. We have six pigeonholes, and every pigeonhole here we will have one, right? We will have one. So it is, we have a remaining student here, which is another one. So we have 6 pigeonhole, every pigeonhole 1 student, and add the remaining student here. So this 6 plus 1 will give you 7 students, right? 7 students. So the answer here is B. Okay. Now question 3 here. Question 3 is about finding the pattern. It's about finding the pattern here. So how can we find the pattern? You just follow the rules, right? You just follow the rules here. So we can go through every row. So every row we have the blank, right? We have the blank shapes. The blank shape is always 1 triangle, 1 square, and 1 circle, right? How about the shaded? The shaded for every row, it is also 1 square, 1 circle, 1 square, and 1 triangle, right? You can see, for the shaded and the blank parts, we always have 1 circle, 1 triangle, and 1 square. So it means for the last row, also 1 triangle, 1 rectangle, and 1 circle here, right? So which part is missing? The circle part is missing, right? The circle part is missing. So for both shaded and the blank part, we will always have the circle. So that's why we choose the B here, right? That's why we choose the B here. Okay, question 4 here. Question 4 is about, it is about something in the number series. So we have 4 stakes placed in a 120 meter track. And yes, we want to find the smallest number of stakes. So the stakes, it is divides the track into several parts, right? It is divides the track into several parts. So here, the minimum stakes means what? Means the maximum silence, right? Means the maximum silence. And also divided into equal lengths. We see the equal lengths here. Once we see the equal lengths, it means the length here for the silence. The silence here, it should be factors of 3 distance. Right? It should be factors of the 3 distance. And then you can combine these 2 conditions together so that you can find we have the maximum and we have the factors. So it is asking about what? It is asking the highest common factor. It is asking the highest common factor. So we need to find the highest common factor of which numbers? Of the 24 here, of the 30 here, of the 36 here, right? The highest common factor of the 3 numbers here. So how can we get it? We do the prime factorization, right? We do the prime factorization. So 24, we can know it is 2 cubed times 3. How about 30? 30, if you do the prime factorization, you can see it is 2 times 3 times 5. And how about 66? It is 2 times 3 times 11. So based on it, we can know the HCF, right? The HCF, it is, we take the minimum exponent for every prime factor, right? So we have 2, the minimum here is 1. 3 here, minimum exponent is 1. And 5, 11, we have the minimum exponent as 0 here, So it is just 2 times 3 will give you 6. So we know the highest common factor for it, it is 6. So based on the 6 meters, can we get the answer here? Of course we can, right? It is just we know we have 120 in the total length, and every side length it is 6. So we know we can put 20, right? We can put 20 in it. And as we know, we need to have to add both ends here, right? We need to add the both ends here. So we need to plus a 1. It is something like the planting tree problem, right? We need to plus 1 for the both ends. So it is 21. So is the 21 our final answer here? No, it is because we have already got 2 here, right? We already get the 2 stacks here. So it is 21, we minus, 20. And as we know it is the stacks here, it is we minus 1, right? It is we minus 1. So once we minus 1, it is 19. And then we minus the already get 2 here. So we know it is 17 stacks. Right. So we divide, we know there are 20 parts. And then it is, we just minus 1 for the stacks, which is located in the middle. Because the 2 ends does not count, right? The 2 ends does not count. So it is why we minus 1. Right. If we count both ends, it is plus 1. So that's why we get 17 here. Okay. So question 5 here, Tom is reading a book and he reads 24 pages per day, and after 5 days there are 3/5 of the books being left unread. So here we can first calculate the pages read in 5 days, right? So what is it? Every day we read 24 pages. So it's 24 times 5 will equal to 120 pages, right? We know it is 120 pages. And the 120 pages, it is which portion of the book here? It is 1 minus 3/5 equal to 2/5 portion of the book, right? This is the reading part. So we know 2/5 of the book is 120 pages. So how about the total number of the pages for the book? 120 divided by 2/5, right? So it will be 120 times the reciprocal of 2/5, which is 5/2. So we will get 60 times 5, 300, right? We know it is 300 pages. Okay. Okay, for question 6 here, question 6 is about, you can see there's a grid. So once you see the grid here, you can think about the Pick theorem, right? Can we use the Pick theorem here? First, we examine it, right? So it is an enclosed shape, and if we go through the parameters, there are all 3 lines, no intersection point, and all the vertex is on the grid here. So it means we can use the Pick theorem. So, do you still remember the Pick theorem formula? It is the number of squares. It is the number of squares equal to the inner dots, right? The inner dots plus border dots divided by 2 and minus 1. This is it, right? So we need to calculate 3 things. First is the inner dots, then is the border dots, and after it, we can calculate the number of squares times the area. We get the total, right? We get the total. So first we need to count the inner dots. How many inner dots inside the shape here? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we have 8 inner dots. And how about the border dots? The border dots, we start from here. Okay, you can start any point, right? We just go through all the parameters, right? We go through all the parameters. So if we start with from here, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, we know we have 20 as the border dots. So we can count the number of squares here, right? By using the formula. It is the 8 inner dots plus border dots here. It is 20. And we divide by 2, minus 1 here. So we can see it is 18 minus 1 will give you 17. You can see the total area of the shaded part of the shape here, it equals to 17 small squares. So we can calculate the area, right? Because we know the area for one of the small square. It is horizontal, vertical, both are 1. So it means the area here is 1 times 1, right? So 17 squares, and every square it is 1 times 1 will give you 17 times 1. Answer here, 17. So which one is correct? None of the above is correct. So we choose E here, right? So we choose E here. Okay, so now let's go to the question 7. Now let's go to the question 7 here. So on the map we have 5 countries, so it is like 5 colors for every country. Wow, it's interesting. So we want how many ways to color them. So here, we need to start with which country? We need to start with the one having most neighboring countries. Right. So among it, which one has the most neighboring countries? The E here, right? E has 4 adjacent countries here. So we start with E. So E here, we have how many choices? We have 5 choices because we know we use 5 colors for the coloring here. So we have 5 choices. And then we can go for the A here, right? We can go for the A here. A cannot have the same color with E. So here A has 4 colors. How about D here? D cannot have the same color as A and E. So as we know, it is 3. Right, it is 3. How about C here? Also, cannot be the same color as E and D. So it is 5 minus 2. It's not 3 minus 1. Okay. It is, among them, we have 5 choices and 2 of them already being used. So it's 5 minus 2, giving you a 3 here. Right. And then, how about B? So B here, we need to have a discussion. Why? Because it is adjacent to A, E, and C. And can A and C having the same color here? Yes, they can have the same color, right? A and C can have the same color. If they have the same color, B here only have 2 colors being eliminated. So B here has 3 choices. But if A and C are different, so 3 colors are eliminated. So we only have 2 choices here. So we need to have a discussion for the color of C here, right? So here, we cannot directly write the 3. We need to discuss it. So if C here has the same color as A, has only 1 choice here, right? The same color as A. And there are 2 choices for the color different from A. So how about B here? How about B here? It is just what we have discussed, right? If C has the same color with A, we can see we have 3 choices. If they have the different color here, we have 2 choices. So we can see the answer here, right? We can see the answer. It is something like the addition and multiplication principle, right? First, we see if C and A are having the same color. It is the weight for 5 times 4 times 3 times 1 times 3. It is because we just get the colors at the same time, right? We color the countries for the same time. And if they are having the different colors, right? Another category here. So we add here, it is 5 times 4 times 3 times 2 times 2, right? So this is how we calculate it. If you calculate the things out and do the correct calculation, you can find it's 240 ways. So yes, we have 240 ways for coloring this kind of regions, right? Coloring it. So we have 240 ways. The answer here is C. Okay, the answer here is C. Alright, the question 8. Okay, question 8, it has a so long story here, which we have a very, very long story here. But don't be afraid, because once you know the rule of we selecting the students, it is super, super easy. So here, let's first discuss. For the first round, right, for the first round. The remaining students, can you find some common characters about the students being remained? So, it is 1 to 11, then the 11 remain in here. And another 1 to 11, 11 remain. So it means the first round, the remaining students here should be the multiple of 11, right? 1 to 11, 11 being left. 1 to 11, 11 being left. So it is the multiple of 11 being left, right? And then, how about the second round? So for the first round, the remaining here, it is all the multiple of 11, right? And then, based on this multiple of 11 here, we just do it again. 1 to 11, 11 remaining here. 1 to 11, 11 remaining here. So it is, among this multiple of 11, we choose, or we label 1 to 11 again, and leave the multiple of 11 here. So it is the multiple of 11 times 11 being remaining here, right? So it is 1 to 1. So how about the third? So all the students remaining here is the multiple of 1 to 1. And then we label it 1 to 11 and 11 remaining here. So we times another 11 for the students being remained for the third round, right? So it is multiple of 11 times 11, and then we times another 11. So this is the character for the third round remaining students, right? So we can see it is 1331. The answer here is E, right? So 1331, the first multiple of 1331 is just 1331. So that's why we choose the E here. Okay? Alright, now let's go to question 9 here. Question 9 is we give distinct 10 non-zero natural numbers, and we know we just take 3 out of them, and we know the ratio is 5 to 6. So what is the maximum product? So it has 2 different topics. The first one, it is the ratio problem, and another one is about the maximum problem, right? It contains 2 parts. So let's go through the first part, right? The sum of the selected 3 numbers. It is what? So we know the total here is 5 to 6. So the total here is 5 parts plus 6 parts. It is 11 parts, right? And among these 11 parts, the 3 numbers here occupy how many parts? 5 parts. So this is the total portion for the 3 numbers here. And we know the total is 11 parts, right? And after it, we know the sum here, it is equal to 55, which is all the 10 non-zero numbers. We have the sum here being 55. So it means we just times the total, right? So we can get the ratio for the 3 numbers here. So it is, we know this one is 11, 11 times 5, 5 here. So we know the answer here for these 3 numbers. The sum here is 25, right? We know the 3 numbers we selected having a sum of 25. And then you can see the 3 numbers here have a fixed sum, and we want the maximum product. So if we want the maximum product, how can we do it? We just make the difference between the 3 numbers being as small as possible, right? So how can we ensure the difference between them is as small as possible? Yes, we equally distribute them, right? So how about we equally distribute the numbers? It is 25 we divide by 3, right? Because there are 3 numbers. So you can see it's 8 remaining 1. So it will give you the distribution like 8, 8, and another remaining 1 to 8 here become the 9. So here, is that the final answer? No, because you can see it is asking 10 distinct non-zero numbers. So we have 8 and 8. They are 2 same numbers. So we need to make them distinct. How can we make them distinct and ensure the difference being the same? We make the smaller one being 1 smaller and the bigger one being 1 bigger, right? So it will change us to 7, 8, and 10. So this one is the final one, right? The final 3 numbers we take out. So we know the answer here is 7 times 8 times 10 will give you 560 here. So we know the answer here is D. Alright, the answer here is D. Okay, now question 10. Question 10, it is about the prime number here. And we have a TASMO number being the sum of 2 prime numbers and the difference of 2 prime numbers. So once you see the prime, and also you see the calculations such as sum, difference, multiply, divide, right? So once you see these 2 kind of elements, you need to think about the parity here, right? You need to think about the parity. So here, it means if we have a prime number, so for prime number, most of them, it should be odd, right? It should be odd. So odd here, which 2 number will give you an odd sum? Odd plus even, right? Only odd plus even will give you an odd sum. How about the odd difference? The difference of them being odd. Yes. Also, we need to find it is the odd minus even or even minus odd. So based on it, you can see among these 2 prime numbers giving you the TASMO number, right? If we will always have an even number, and the even number, it is also prime, because the 2 prime numbers, right? The even number is also prime. So we can see the even here is 2, because 2 is the only even prime number here, right? So here, we know the even here is 2. So then we can see right? Then we can see the TASMO number plus a 2, it should be a prime. Right? The TASMO number minus a 2 also should be a prime. Right? Based on this thing, you can just get these kind of equations. TASMO plus 2 is prime. TASMO minus 2 is also prime. And also, we want to find the minimum value of the product of the next 3 odd numbers after the TASMO number. So it means what? It means the 3 numbers, the 3 odd, should be minimum, right? So if the 3 odd numbers should be the minimum, it means what? It means we can make the TASMO number being the minimum, right? We can make the TASMO number being the minimum. So we can just start to list out here, right? So we have 2, 3, 5, 7, 11. Okay, so we can stop here. Why? Because we can have already find a pair that meets the requirement, right? So we have 5 here. It has 2, right? 3, not. 5 minus 2 is 3, which is a prime number, right? 5 plus 3, which is also 7, a prime number. So we know the 5 here is a TASMO number. So how about the 3 odd? It is just 7, 9, and 11, right? It's just 7, 9, and 11. So if we time it, you will get the 693 here, right? You will get the 693 here. So we know the TASMO, the product of the 3 odd numbers after the TASMO number, it is 693. B here. Alright. So for these kind of questions, do you have any problems? Right? For the first MCQ part. Do you have any problems here? Okay, so it is easy and nobody is giving any problems, so let's start it. Let's go start it. Okay, so let's go to section B. The section B is about the short answer questions. So here we have 10 short answer questions for 3 points. Okay, so the first one is about what? The first part is about what? If the product of all the digits here is a positive integer and it is odd, yeah? So we call the number a good number. Oh, so this kind of question is also about the parity here, right? So which one will give you the odd positive integer, right? Which one will give you a positive product? We need to think about it. So here, if the product here is odd, right? So the odd product, it is about what? The odd product, it means the factors should also be odd, right? Can only become the odd times odd will give you an odd product, right? Only become the odd times odd. Once we have the even number, it will give you an even product, right? This is the character about the odd and even when we multiply them. So you can see the product of the 4 digits is odd. It is equal to what? It's equal to all of the digits here is odd. Because once we have an even digit here, it will make the whole product being even. Right? Once we have even, the product here will be even. So all of the digits are odd. So here, we just calculate how many good numbers here, right? So we have 4 digits here, so 4 vacancies. So for the first vacancy, we have how many choices? 5 choices, right? 1, 3, 5, 7, 9. We have 5 choices. And it's also the same for the 100th place, the same for the 10th place, the same for the 1st place, right? So we just multiply them up. So it is 5 times 5 times 5 times 5. Right, the 4, 5 times together, so that we will get 6 to 5 numbers here. So we can see we have 6 to 5 numbers giving you the weight, right? Giving you the weight. Okay. So question 12. Oh, question 12 is about defining a new operation here. So we have circle, okay, giving you a plus b times a minus b plus b times 3. And we have 23 times pi. Wow. We have a pi here. So it's quite annoying, right? It's quite annoying. So first, we need to find out how can we make the 23 circle pi into it. So here, we just follow the pattern given by the A circle B here, right? So 23 circle pi. Among it, which one is A? 23 is A. Which one is B? Pi is B. So we can know the A plus B times A minus B plus B times B. It will be substituted as 23 plus pi times 23 minus pi plus pi times pi. So based on the previous term, you can see 23 plus pi times 23 minus pi. It is a formula, right? So the answer here is 23 squared minus pi squared. How about the pi times pi here? Also a pi squared. So you can see it is a minus pi squared plus pi squared. They cross out. So it is 23 squared here will give you the answer of 529, right? So you don't need to care about the value of the pi here. You just only need to follow the pattern, do the substitution, and then, yes, you will know the final answer here, right? It's not that hard. Okay, question 13. Okay, it is about counting the triangles. So yes, we need to find the total number of the triangles. So we have two ways, right? The first method is about adding the line. The second one is we count by categories. So here, right, I want to use the method about the counting by categories because I think this way is an easier way to solve it. So here, how can we divide the triangles into different categories? So here, we can divide the triangles into, they are formed by how many different base triangles, right? So first we can calculate the triangles with one base triangles. So how many are there? We have 1, 2, 3, 4, and 5, right? We have 5. And then the second category, it is about the triangles composed by two different base triangles. So for example, this one is one of it, right? This one is one of it. So how many are there? We have 1, 2, 3, 4, and 5, right? We have 5. So here we have 5 triangles composed by the two triangles. And of course, do we have the triangles composed by 3 different base triangles? Yes, we also do have one. Right? We also do have one. So it is located here, the blue triangle, right now. Yeah, so it is located here. So how can we find it? How can we get the value here? It is just, we add all the things up. We add all the things up. So it's 5 plus 5 plus 1 will give you 11 here. So we know the answer here is 11. We do have 11 triangles being counted here. It is just, you count all the categories and you determine every category has how many triangles and add them up. Then you will get it. Right, then you will get it. So, this is how we do it. Okay, so now let's go to question 14. Question 14 is, a rate problem. So we have a project being completed by A alone in 1 day and being completed by B alone in 8 days. So how can we do it? So here, for the rate problem, right, if we cannot find the rate for A and B, we can just set the whole workload being 1, right? So, if we know, alright. So, if we know the whole workload is 1, then we know A completed alone in 10 days, B completed it alone in 8 days. So we know the rate for A and B, right? So 10 days to complete the work being 1. So every day 1 divided by 10, right? So it is 1 over 10 of the workload per day. How about B? Also 1 divided by the time he finished. So 1 over 8 per day. So then we know the rate for both A and B here. Then we can calculate the days for A to work in this kind of situation here. Right? So we can set A work for X days. So once we know A work for X days, we can just express the whole situation by equation here, right? So first, A work for several days. So X times 1 over 10, right? X times 1 over 10. And then B continues to complete it in 9 days. So it is 9 minus X. It is a days for the B to complete. And every day, B finishes by 1 over 8 here. So we know the answer here is the total workload. So it is 1, right? So once we plug them, we can just open the bracket and solve this kind of equation, right? We have built the equation here. So it is, we open the bracket, so it times this one with 9 times 1 over 8 with the X and remain the symbol here, right? So it is 1 over 10X plus 1 over 8 times 9, so 9 over 8. And minus X times 1 over 8 minus 1 over 8X. So we'll see it is 1. Right? So we make we make the numbers become one side and X become another side. So it is 9 over 8 minus 1 equal to 1 over 8X minus 1 over 10X. Right? So then you can see 1 over 8 of the workload, it is completed by 1 over 40x. It is completed by 1 over 40x, right? So then, x here will give you the number of 5, right? So we know the answer here is 5 days. So they will complete the whole work in 5 days here. All right. Okay, question 15. Question 15. Oh, the integer parts of the 3 finite decimals is 5, 4, 5, 6 respectively, and we want to know how many possible values here. So we don't know what are the we don't know the exact value for these 3 decimals, right? But now we know the integer part. It is 4, 5, and 6, which is giving you the range, right? Which is giving you the range. So it is based on this range, we can use the estimation for us to do it, right? We can use the estimation to help us do it. So how can we do? So for the estimation here, we need the lower bound and the upper bound, right? So the lower bound. The lower bound for the product here is we make every factor here get the lower bound. So it is 4, 5, and 6, right? So we times them together. So it will give you 120. But as we know, it includes 4, includes 5, includes 6. So this 120 is also included. How about the upper bound? The upper bound, it is, we take 4 plus 1, 5, right? It is 4, 9, 9, 9, 9, 9, 9, 9, 9, 9, right? Quite close to 5. And how about the second one? 5, 9, 9, 9, 9, 9, 9, 9, quite close to 6, right? And the third number, close to 7. So if we time them together, it will be 210 here. But you can see, the first number cannot be 5. The second number cannot be 6. The third number cannot be 7. So the 210 is not included here. So now we know the lower bound, we know the upper bound, and we know the two sides. One side include, the other side not include. Right? So it is something like the planting tree problem. Right? So here, one side include, another side not include. So it is just we minus. We don't need to add 1 or plus 1 here. Right? So the answer here is just 210 minus 120 will give you 90. Right? For one side include, the other side not include. Just minus, no need to add, no need to minus. So the answer here will give you 90 possible values here. Right, 90 possible values here. Alright. Okay, so now let's go to question 16 here. Now let's go to question 16. So here, as shown in the figure, a regular hexagon is divided into 6 triangles and yeah, also 3 identical. So once you can see, we have a division here. So we can divide the whole part and find the portion to solve it. Right? We can use the portion to help us do it. So here, how can we find the portion? We need to cut the whole figure. We need to cut the hexagon into different small base parts, right? Every base part is equal. And then we can count. The shaded part is how many base parts, the total is how many base parts, and then we can get the proportion about it. Right? We can go the proportion about it. So how can we cut it into small pieces? So can you find the small pieces here? Yes, the small triangle here, it is something like the base parts, right? So we can cut the hexagon into small triangles here. So how can we cut? This one, cut it into 3 also, right? This one, cut it into 3. And this one, also we cut it into 3 parts. So once we do the cut, we know the total here is how many small triangles. So first, we cut them into 6 equal triangles, right? And every small triangle, we can cut it into 3 base triangles. So 6 times 3 will give you 18 triangles in total. And how about the shaded part? The shaded part will give you how many shaded triangles here? So you just count 1, 2, 3, 4, 5, 6. Yeah, we have 6 triangles here. So once we know we have 6 triangles, we get the proportion about it, right? The ratio for the shaded and the total here is the 6 triangle to 18 triangles. So the answer here is 1, 2, 3. And we know the area for the shaded, it is just 18. And the total, we don't know. But we know the ratio is the same, right? The ratio here is the same. It does not change. Also 1, 2, 3. So we know the total here, right? The total here, it is just 18 times 3. So it is 54 cm squared. Right? We know the answer here is 54 square centimeters. Alright, so this is it. So based on it, if you can see, yeah, we cut the whole shape into several different parts, several identical parts. Then just imagine, how can we cut them into several identical parts and use the ratio to help us solve it, right? This is super fast. Okay, question 17 here. Oh, question 17 here is a number sequence. So we have an arithmetic sequence. The 8th term is 41 and the 12th term is 53 here. So yes, once you see the arithmetic sequence, there are 2 parts which is quite important. The first part is the first term. The second part is a common difference, right? But do we know the first term and do we know the common difference here? No, we don't know. We only know the 8th term and the 12th term. But fortunately, we can just express the 8th term and the 12th term by using the first term and the common difference here, right? So we can just set it. We set the first term being A1 and the common difference being the D here, right? So the 8th term, A8, it is from the A1 and A2, 1 common difference, A3, 2 common difference, so A8, 7 common difference here, right? How about A12? A1 and 11 common difference here, right? We know the 8th term is 41, the 12th term is 53. So we can get the answer here, right? We can get the answer for the, based on this 41 and 53 here. So we can just use A12 minus A8. So you can see it is A1 plus 11 common difference minus A1 minus 7 common difference will give you 53 minus 41. So you can see A1 we cross out. So there's 4 common difference here being equal to 12. Right. So the common difference here being 3. So based on the common difference being 3, we know the value of A1, right? So here we know 7D is 7 times 3. So A1 plus 7D it is A1 plus 21 equal to 41. Right. So we know A1 here is 41 minus 7 times 3. So it is 20. Right? We know the first term is 20, and now the common difference here is 3. So how about the 23rd term? It is the first term plus 22 times the common difference. So if you just substitute the A1 and D into it, right? So we know it is 20 plus 22 times 3 will give you 86 here, right? So we know the 23rd term is 86. Alright, the answer here is 86. Alright, question 18. Alright, question 18 is about the ratio problem. So P5, 40 students at the initial stage, it is boys, and the other are girls, right? So for the school, we have boys and girls. And for the initial stage, 40% of them are the boys. So we can set it as 4 over total of the 10, right? So total here, I set as 10 units. And the 40%, which is 4 units here, being the boy. So how about the girl? 10 units minus 4 units. So 6 units higher are the girls here. And then, we have transfer the boys and girls. So after the transformation, right? After we transfer the boys and girls, so what will happen? So 10 boys are transferred out. So it means the number of boys here get minimized by 10, right? Get 10 less. So it means 4 units minus 10. 10 boys go out. And how about the girls? 20 girls transfer into the level. So it means the number of girls being 20 more, right? We have 20 more girls here. So here, right, we know the boys made the 35%. So the ratio for the boys and girls is 35%, and the total here is 100%, right? So it is 35% to 65%. So it is 7 to 13, right? So we know the ratio after the transformation for boys and girls is 7 to 13. And we have expressed the boys and girls by the units here. So we can just build the equation. 4 units minus 10 to 6 units plus 20 will be equal to 7 to 13 here. So based on this equation, can we just solve the units here? Yes, we can. We use the inner parts times inner parts and outer parts times outer parts. So you can see it is 42 units plus 140, which is the product of the inner parts, right? 42 units plus 140 will be equal to 52 units minus 130 here, right? So you just solve this equation, right? So it is 10 units will give you 270 here. Unit here is 27. Right, so it is asking how many girls are there in the level now. So we know the answer here. It is asking this part, right? 6 units plus 20. So it is 6 times 27 plus 20, right? 6 times 27 plus 20. So it will give you 162 plus 20, 182 girls. Right, it will give you 182 girls. Alright, this is how we solve it. Okay, question 19. Ben is driving from A to B for a business meeting, and me drives at the speed of 80, arrive at 4. Drive at speed of 120, arrive 2 hours earlier. So this is a journey problem. But here, do we know the time traveled by Ben? For the first situation and the second situation, do we know the total time here? No, we don't know, right? So this is quite important because we don't know the distance, but we know the speed. The only thing about it is about the time. So we don't know the time. Then what should we do? We can just set the time here being x, right? So we let the traveling time being x hours. So here, the total distance is he traveled for x hours and at a speed of 80 kilometers per hour. So the distance it is 80 kilometers per hour and times x hours. This is the total distance. And also, it can be expressed as traveled at a speed of 120 and arrived 2 hours earlier, which means the time decreased by 2 hours, right? 2 hours earlier means these 2 hours, he do not need to travel. He is already there. So the traveling time decreased by 2 hours. So this is another way for us to express the total distance, right? So here we have built the equation, so try to solve the x. 80x is equal to 120x minus 240, right? We open the bracket. So it is 240 equal to 40x. X for one side, the other for other side. So we know the x here, it is 6. Yeah. So we know the total traveling time, it is 6 hours. And then he will arrive at 4 p.m. So now, if we want him to arrive at the 3 p.m., the time here should be what? So based on it, 3 p.m. it is 1 hour earlier than the 4 p.m. here, right? So if he needs to arrive at 3 p.m., it means he needs to arrive 1 hour earlier. So it means the total time for his traveling, it is 1 hour smaller, right? 1 hour smaller. So it is 6 minus 1 equal to 5 hours. It is equal to 5 hours for the traveling. And then we want the speed. So we also need to figure out the distance. But fortunately, we know the distance, right? We know the distance. It is 8 kilometers and we travel for 6 hours. So not 80 kilometers and we travel for 6 hours. So it is 480 kilometers here, right? So we know the speed. It is a difference, not the difference. It is a distance divided by the time here, right? So it is 480 divided by 5 will give you 96. Yeah, 96 kilometers per hour. So we know the answer here being 96. All right. Okay, for the question 20. Question 20, it is a little bit hard because it combines a lot of knowledge points here. Yeah, we need to know a lot of things. But yeah, it's not that hard. Of course, it is not that hard because every knowledge point, it is easy. Right? It is easy. So yeah, it just corresponds to how you just get familiar with these kind of knowledge points. Right? So let's go through the question first. We have E and F located on the sides of AD and AB. And yes, we know FG to DG is 2 to 3. Right? FG to DG is 2 to 3. And we know HBC is 24 greater than HGD. And it's nothing else. Right? It's nothing else. And we need to calculate the ABCD. So how can we do it? So once you see HBC is 24 greater than HGD, something is some value greater than another one. You need to think about, we need to add the common parts for both sides and do the transformation, right? So here, we know the area of the triangle HBC, 24, larger than the area of the triangle HGD, right? So can we add some common parts to make one side being a regular shape? Yes, we can add the common parts for the DHC here, right? We can add the common parts for the DHC here. So we add the area of DHC on both sides, and the difference will not change, right? Will not change. So once we add it, we can form the triangles into new triangles, right? HBC plus DHC, it is what? It is the area of the triangle DBC, right? It's a triangle DBC. And also, HGD plus triangle DHC, it is what? It's a triangle DGC, right? So it is equal to 24 plus the triangle DGC. So, based on it, how can we get the value here? So for this, we have get it to one end, right? But still we cannot find the answer, so we need to use another condition we have not used, which is FG to DG is 2 to 3 here, right? So how can we just think about the 2 to 3? How can we make use of it? So you can see, the things here, we get DBC's area, we get DGC's area, right? It's about the area. So once you get the area, we need to think about the base and height here. So here, we can just transfer the ratio for the sides into the ratio of the height here, right? So how can we transfer the height? Yes, we just do the height. We just draw the height out. So once we build the height, for example, GH, HIJ. So we have GH, HI. So Fi here being one height. Right, we have Fi here being one height. And we have Gj here being another height. So based on it, we know Fg to Gd is 2 to 3. So how about Fd to Gd? How about it? Fd, it is equal to Fg plus Gd, right? So it is equal to 2 plus 3 to Gd, which is 3 here. So we know the ratio here is 5 to 3. We know the ratio here is 5 to 3. So after it, yes, we can just express the DGC by DC and GJ, right? But how about DBC? So how can we just express the DBC here? So you can see, B here is on a side of the rectangle, right? And DC here is also on another side of the rectangle. So you can see, the two sides here are also parallel, right? They are also parallel. So once you can see, a point is on one of the parallel. The base is on another parallel line. You need to think about what? You need to think about the triangles with the same areas here. So here, we can do the shifting, right? We connect the FC. So you can see, DFC and DBC, they both share the base of DC. And B and F are on a parallel line to CD, which means the height here is the constant. It will not be changed. So we know the DBC here will have the same area as the triangle DHC, or not DHC, DFC. It will have the same area of the DFC. So here, we know DFC, it will be equal to 24 plus the triangle DGC, right? So can we just express the DFC here? Of course, we know Fi, we know the height here, right? So the triangle DFC, it is what? It is the base DC times the height Fi, right? Base DC times the height Fi, and divide by 2. Base times height divided by 2. And how about the triangle DGC's area? Also, base DC times the height Gj, and divide by 2. So we can see the ratio of these two triangles is the ratio of the height. Do we know the ratio of the height here? In fact, we know it. Why? Because we know FD to GD, it is 5 to 3. And also, if you take FDI and GDJ out, you can see they are the similar triangles. Yeah, they are the similar triangles. So it means the Fi to GJ, they are also the same ratio as FD to GD, right? The similar triangle will give you the ratio of the sides being the same. So you can see Fi to GJ, it is 5 to 3, which is also equal to DFC to DGC, right? Because the base here is the same and divide by 2. The ratio of the area is just the ratio of the height. So yes, we know it is 5 to 3, right? So here, we can set it at 5 units and 3 units. So 5 units, it equals to 24 plus 3 units. So we know it is 2 units equal to 24. Unit here is 12, right? Why we know 1 unit is 12, but we want to know is the area of ABCD. So how can we get the area of ABCD based on this unit? We have another model, which is called the half area model. So which one is the half area of the ABCD? The DFC is a half area of the ABCD, right? Do we know the area of the triangle DFC? Yes, we know it is 5 units, right? So it is 5 times 12 will give you 60. And we know it is a half of the area ABCD. So we know ABCD's half, it is 60. How about the total? The total here is just ABCD. The 60 times 12. Half times 12. Not 12. Half times 2. Right, half times 2. So it's 120. It is 120 here. We know the area of the part. It is the 120. Yeah. So this is it. Yeah. This kind of geometry question, we need to think about a lot of knowledge points. But every part of it is not that hard. Okay. So now, any questions for the section A and section B? Yeah. Any questions for section A and section B? No questions? If no questions, then I continue here. Okay. What was question 7? The question 7 here, I think, a coloring problem. It is 420. Right, it is 420. It is just, you just discuss whether the two countries have the same color, and you use the addition and the multiplication principle so as to get the final answer. Alright. Okay, so if no questions here, then I continue for the section C. So for section C here, yeah, same letter stands for the same digits. So here, of course, you can try the number A, B, C, D here, right? You can have a try for the carryovers and do the traditional way to do it. But here, we have a super fast way to solve this kind of question. What is the way? You use the place value principle. So here, we have A plus AB plus ABC plus ABCD, right? A here is A. How about AB? AB can be expressed as 10A plus B, right? 10A plus B. And how about ABC? 100A plus 10B plus a C, right? How about ABCD? It is 1000A plus 100B plus 10C plus D, right? Once you open the bracket, you will find it is 1111A plus 111B plus 11C plus D equal to 7540, right? So then you can just estimate the value for 111B plus 11C plus D, right? So 111B, it is of course larger than 0, right? Every number here should be the positive integer. So 111B plus 11C plus D, right, should be larger or equal to 0. And also smaller or equal to everything become 9. Right. So it will be equal to 1107. So we know 1111A should be smaller than the 7540 minus 0, right? 7540. And being larger than 7540 minus 1107. So we know it is between the 6433 and 7540. So based on this, we can see A here only have the value of the not 7, only have the value of 6. Sorry. Because if A here is 7, it is 7777, right? Larger than 7540. If A here is 6, 6666, just inside this kind of range, right? Just inside the range. So then we can just minimize the 1111A here, right? So we know 111B plus 11C plus D here is 7540 minus 6 times 1111, which is 6666. So we know 111B plus 11C plus D, it will be equal to 874. And you do the same, right? You do the same procedure. You estimate B's range. So you can see 111B, it is smaller than 874, and also it is larger than 766. So B here is 7, right? Only 777 will meet the requirement. So then 11C plus D here is 874 minus 777 will give you 97. And then you do it again. C here will become 8, D here will become 9. Right. So we know ABCD here will be equal to 6, 7, 8, 9. Right, it will be equal to 6, 7, 8, 9. Alright. Alright, so question 12 here. Okay, so once you see question 12, it is about the angle calculation, and we know JAB GBA is 42 here. Okay, so now based on it, we can, once we see the 42 here, yeah, we can just use the exterior angle theorem, right? We know the angle of the FGB. So FGB, it is just a 42 plus 42. Why? Because the exterior angle theorem will give you the sum, right? So 84. We know the answer here is 84 for FGB. So also, we can make the FGB become two angles combining up together, right? It is the FGE plus the angle EGB. Right, it is this part. And also, the EGB here, it is also equal to the triangle CGD. Why? Because they are the cross angle. The cross angle is the same. Right. So we can express the 84 degrees as the FGE and CGD. And then, we know GFE equal to 2 times GCD. So how can we use it? So here, FGE, we know it is here, right? And CGD, we know it's here. And also we know this is 90 degrees, this is 90 degrees. And GFD, it is this part. And GCD is the other part. So here, you can see, for the two triangles, all of the six angles have the relationship. Right, we have already found the relationship. So yeah, we need to think about the interior angle sum about the triangle here. So for every triangle, the interior angle, we sum it up, it will be 180 degrees, right? It will be 180 degrees. So you can see the angle GCD plus the angle CGD plus the angle CDG. And we know CDG here 90 degrees, right? We know here it is 90 degrees. Will be equal to the sum of the triangle, which is 180. And also, we can do it again, right? The GFE. And GFE, we know it is 2 times angle GCD plus the FGE plus the FEG. And FEG, we know, yeah, it is also 90 degrees, equal to 180. So then we can express the FGE and the CGD, right? So here, CGD, it is, we just use the 180 minus 90 minus the GCD, right? So it's 90 degrees minus the angle GCD, right? Minus the angle GCD. How about the angle FGE here? The angle FGE here is also 180 minus 90 degrees, and also we minus the GFE, which is 2 times angle GCD. And we know we can express the GCD by the, or we can express the two angles by the GCD here. And we know the sum of them is 84. So yes, we build the equation. 90 degrees minus the angle GCD plus 90 degrees minus 2 times the angle GCD. It will be equal to 84. Right, 3 times the angle GCD will be equal to 180 minus 84. So 3 times GCD will be equal to 96. So angle GCD here, we know it is 32 degrees. And is 32 degrees, is 32 our final answer here? No, it is asking the GFE. GFE, we know it is 2 times the GCD here. And we know GCD is 32. So it is 2 times 32. We'll give you 64. Yeah, so we know 64 degrees is the final answer. Alright. Question 23. Inclusion and exclusion problem. So here, yes, in the first test, we know 5/7 of the students scored above 40. So, first test. Who or how many students scored below 40 here? It is 35 students in total and the remaining portion of it, right? 1 minus 5/7. So it will become 10 students having less than 40, right? How about the second test? You do the same, right? You find out the remaining portion and times it by the total. So it is 35 times 1 minus 4/5 will give you 7 students. How about the third test? Also, total here 35 and you minus the remaining portion 6/7. Will give you 35 times 1/7, 5 students. So now we have already calculated how many students get below than 40 in every test, right? And what is it asking? It is asking scored above 40 in all 3 tests, right? And it is at least. We are calculating the minimum. So here it is above 40 in 3 tests, being maximum. So this kind of question, it is equal to what? It is equal to the students get at least one of the tests less than 40 being the maximum, right? On this one is the minimum. It is asking at least, right? So this minimum is just like asking you the students get at least one of the tests less than 40 being maximum. So altogether we know 10 students failed in first, 7 students failed in second, 5 students failed in third, right? So once, if we have a student get less than 40 in both first and second, is it the maximum here? It won't be the maximum, right? It won't be the maximum because we have just not make use of 1 student in the second test. So here, we just make every student get failed or get less than 40 in one of the tests. So then we can ensure the students get at least one of the tests less than 40 being the most, right? So it is just less than 40 in at least 1 test being maximum. And we know this maximum, it is just, we add all the things up, right? We make every student just less than 40 in 1 test. So we know it is 22, right? So the maximum of the students who get at least one of the tests less than 40 being 22. So yeah, you can see, it is just for every student. It is either get more than 40 in 3 tests or get at least 1 test less than 40, right? So it is just we use the total minus this maximum, so we can get the minimum, right? 13 students. So we have 13 students. Right. Now question 14. Okay, question 14. Yeah, we have a square and yes, we want to know the shaded part. So we don't know the side length, we only know the diagonal is 24. So it means this part 12, this part 12, this part 12, this part 12. Right. But how can we just calculate them easily, right? So first, we know 4 and 5, and we know 12, 12, 12, 12, right? So it means we know the small rectangle, and we know the one of the 4 triangles inside the square, right? So how can we transform the whole thing into something like the triangle, something like the squares? Yes, we use a cut and shift method. So first, we cut another 4 times 5, and we cut another 4 times 5. So then, these 2 remaining parts are the same. So we can shift this part into this blank one. We can shift this part into this blank one. Right? So we know the shaded. It is this large triangle. And we got 2. Right? And also, there are 2 of them, right? The middle one, it is already being calculated inside the triangle here. So we only have the 2 remaining rectangles being here, right? So we know the shaded part is converted into 2 triangle plus 2 rectangle. And for the triangle, yes, we know base and height, which is 12 times 12 divided by 2, right? And for the rectangle, yes, we know the length and width, which is 4 and 5. So yeah, of course we can calculate the things easily. The whole key for this question is about you find how you cut and shift the whole shaded part. So the calculation here is not that hard, right? Base here 12, height here 12, divided by 2, and we got the 2 triangles here, so we times 2 as it before. And then 2 times the rectangle, length 4, height 5. So it is just 2 go away, 12 square, 144. And it is 2 times 4 times 5 will give you 40. So we know the answer here is 144 plus 40, 184 cm squared. Right, so we know the answer here is 184. Okay, so for this one, question 25. Okay, question 25 is about you just label all the, or you just list all the things that might happen, and you figure out which one is okay, which one will not happen. Right? It's just about you list all the things, and then you find out. So here, first we list out the January here. So for the January, the first 4 digits here, it will be 2501. Right? For the last 2 digits, it can have 0 something, 1 something, 2 something, and 3 something. Right? So for the 0 something, we already have a 0 here, right? No. For 1 something, we already have a 1 here. No. For 2 something, no. How about 3 something? 3 something. For the January here, we only have 30 and 31st, right? So here, 0 and a 1 for the last digit, we already have 0 and a 1 here. No. So January, we cannot have any days being different. So how about February? It's 2502. You can see, no matter how we take the last 2 digits, there are 2 2s here. So of course, nothing will happen. Right? How about March? For March, 2503. Right? Something, something. For 0 here, we already have a 0. So no. For 1 here, yeah, for 1, we have 25031 here. Right? So the other number, it's just not these 5 numbers already existing, right? So this 10 minus 5 will give you 5 numbers here. Will give you 5 numbers here. How about 2 something? We already got a 2 here. How about 3 something? We already got a 3 here. So for March, we have 5 days giving you the correct format. So here, how about April? It will be 2504 something something. For 0 something, no. For 1 something, also 25041. 5 different numbers, so 5 numbers being remaining. 5 choices. 2 something, no. 3 something. So here, 30 cannot be because we have already get a 1. We already get a 0 here. But how about 31? So 250431, it should be the case, right? So here, this time, we have 6. We have 6 numbers here. So how about May here? So for May here, it is 2505 something something. Right. So it means we have 25 here. No. How about June? 2506 something something. And you do the same. 0 something, no. And 1 something, 5, 2 something, no. 30, no. And 31, does it have 31? No. Okay, so now we have July. Oh wait. So here, April we got 6 days. So here, does April has the 31st days? Does April has 31st days? This is something we need to focus on, right? So April, we only have 40 days. So 31, will it exist? No, it won't exist. So this one, yes, not 6. Right, I'll just find out. So here, we also need to find out the last day for the different months. So April, only 30th. So yeah, also 5, not 6. So June here, also 30, right? June here does not have 31. And how about July? 2507, right? July have 31 days. So we have 0 something, no. 1 something, 5, 2 something, no. 31st being correct, right? So 1 choice. So August also the same, right? August also the same. 5 plus 1, 6. So I just omit it. August, we also have 6 days. I use another color. And how about September? The September has 30 days, right? The September has 30 days. So 31st, not okay. But how about the 1? The 1 something, we have 5, right? September also have 5 days. How about October? So from October, November, and December, it will be easy. Why? Because if you list out the number, you will find October, it is 2510 something, right? 2510 something. So 0 here, we already get. 1 here we already get. 2 here we already get. 3 here, only 3 0. Oh, no, we have 3 0 and 3 1. So 3 0, we have 0. 3 1, we have 1 here. So, no. Right. November 2511, we have 2 1 here. No. December 2512, something. Right. We already get the 2 2 here. So, no. So altogether, we can just cut them out. Right. We can just count them out. So it will be 5 5 5 6 6. Oh, June here we also have a 5. Yeah. So we have 5 5 5 5 and 6 6. So we have 5 in 4 months and 6 days in 2 months. Right. It's quite annoying. So 20 plus 12. 32 here. Right. 32 here. Okay, question 26. AMC, and yeah, we know the midpoints here. Okay, so for this one, right. So midpoints, once you see the midpoints, and isosceles triangle, so it means these 4 parts are the same. And then we know MB and CU here, and also we know this is 90 degrees. So they are perpendicular. So once you see the perpendicular, you need to think about the area here. You need to think about the area. So how can we form the area based on the MV and UC? We need to link the UV here, right? We connect the UV, and then we can get the area about the bottom part, right? UVMC. So once we connect the UV, we can also get something interesting. Why? Because we know the ratio of AU and AB to AM and AC. Right. So once we connect the UV, we'll have something interesting here. So the area of the triangle AUV to the area of the triangle AMC here, it is AU over AM times AB times AB over AC, which is 1 over 2 times 1 over 2, 1 over 4 here. It is 1 over 4 here. So we know the ratio is 1 over 4. We can set this as 1 unit, this one as 3 units here. Right. So we know the area of the, not triangle. We know the area of the UVMC. It is 4 units minus 1 unit, 3 units. Because we know it is the AMC minus AUV, right? 4U minus 3 minus U, 3U here. So we know UVMC is 3 units. And do we know the area of UVMC based on the MVCU12 and a perpendicular relationship between them? Yes, we can. Right. So it is about we cut and reform the areas. So how can we cut and reform the areas? So the UVMC's area, it can be cut into the triangle MUV's area plus the triangle MCV's area, right? And MUV's area, we know it is MV times the height UP divided by 2. And how about MCV's area? We know it is the base MV times the height CP divided by 2. And you can see MV divided by 2, MV divided by 2. It is a common factor here. We just combine them. So it is MV times UP plus CP divided by 2. So it is MV times UP plus CP. We know it is CU divided by 2. So we know MV and CU here being 12 and 12. So it is 12 times 12 divided by 2. Will give you 72 centimeters square. Right. So we know 72 centimeters square, it is 3 units. So 1 unit here is 24 cm squared. The answer here, it is asking the AMC. And we know AMC is 4 units here. So it is 4 times 24 will give you 96. Right, it will give you 96. Yeah, so this part is 96. Okay, question 27. Question 27 is about you need to find the pattern inside the number table here. How to find it? So first you observe, you can see everything here is an odd number, is an even number. It's an even number, right? So we just divide by 2 to make it a 1, 2, 3, 4, 5, 6, blah, 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 blah. Right? We just divide by 2. So now the 7102 is how many terms? Once we divide by 2, right? It is 7102 divided by 2. 3551. It is a 3551 term, right? And everything here will become 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. And then you need to find the pattern here. So once you see the every last number in the row, you can see it is 1, 4, 9, blah, 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 right? 1, 4, 9. And 32, also you get 16. So can you find the pattern here? Yes, 1 it equals to 1 square, right? The first row, 1 square. 4 here, 2 square, and yes, they are the second row. The third row, 9, so it is a 3 square. And how about the fourth row? 4 square. So we can see every last number in each row, it will be n square. So we need to find 3551 is in which range, right? It's between which two perfect numbers, square numbers, right? It's between which two square numbers. So here we know 60 square, it will be equal to 3600, right? And larger than 3551. And quite close. So let's try about the 60 minus 1 square, which is 59 square. So for 59 square, we know it is 3481, smaller than 3551. So you can see, yes, 3551, this term is larger than 59 square, smaller than 60 square. So yes, we know it is in the 60th term, 60th row here, right, 60th row. So here, we know the row, but we also need to know it is the which number here, because we know the nth number, right? It is which number. So here, you can see, we just make the difference here. Why? Because once we make the difference, you can see everything is plus 1, plus 1, plus 1. Right? Once we make the difference, we will know which term it is in, right? So it is 3551 minus the first number when we divide by 2 on the 60th row, which is 3481 plus 1. This is the first number on the 60th row. And once we minus, we need to count the both sides, right? We need to count the both sides because it is asking the nth number here. So we need to plus 1 here. So you can find the answer here is 3551 minus 3481, 70. Right. So it is the 70th number. So here we know m here equal to 60, n here equal to 70. So m plus n is just 70 plus 60 will give you 130. So we know m plus n, 130 here. Okay. Question 28. Question 28 is about something in algebra. So here, we know they form a 5-row rectangular cube and is not square-shaped. So here, we can just assume there are 5x students. Because we have 5 rows, right? We can have 5 rows. And it's rectangular. So we can just say we have 5x students, and x here is the color. So then, we know if 24 inside, we have a square. 24 go away, also a square. So we can build the equation here, right? 5x, we plus 24. We add 24 students here, it will be a square. So, a square. And if we deduct 24 students here, also square, so b squared. So based on it, we can find the relation between a and b, right? So we use the first equation minus the second equation, 1 minus 2, will be equal to 24 plus 24 equal to a squared minus b squared. So it is 40a equal to a squared minus b squared. We know it is a plus b times a minus b. Right. So then we know 42 it is a plus b times a minus b. So let's think about the relationship between a and b, a plus b and a minus b. They must be same in odd or even. Why? Because if we are not the same odd or same even, the b here will be something 0.5. It will be something 0.5. And of course, we know a and b are integer. So that's why we need to have them being the same and odd and even. So now we can list, right? Now we can list. So 48 here, it is 1 times 48. It is 2 times 24. It is 3 times 16. Of course, they are not the same priority, so go away. So 4 times 12 and 6 times 8. So 148, no, because they are not the same even or same odd. So 2 times 24, yes. So based on it, we know A here will be equal to 13. B here will be equal to 11. This one, no. 4, 12, yes. So here, A here will be equal to 8. B here is 4. And 6, 8, yes. A here is 7, B here is 1. So then, we can calculate, right? If A 13, B is 11. So, the 5x, which is 11 squared plus 24, right? 1, 2, 5. Larger than 50 students? No. So how about A is 8, B is 4. So it is 5x being 4 squared plus 24, 40. Good. How about A 7, B 1? So it is 5x equal to 1 squared plus 24, 25. A square number. So it is not a square, right? We know it is not a square shape. So 25 cannot be the case. So the only thing being possible here is 40. We know there are 40 students. Okay, question 29. Question 29 is about a journey problem. So here we can just draw the diagram. Right, we can just draw a diagram. So here, this is P, this is Q, and they meet at the C here. They meet at the C here. So we have carriage A go from here to C, and carriage B go from Q to C. And after it, yes, it is half of the speed, and come back to C. And for this one, yes, he just directly go to P here. So based on it, we have just drawn the diagram, right? We have just drawn a diagram. But how can we know how to get it? How can we know how to get it? So based on it, yeah, we don't know the exact value of the speed, but yes, we know this 1600, and we know the second time or the after meeting point. That after meeting point, he go back and forth. It is 2 times. So this is the ratio, right? You can see back and forth 2 times. Something about the ratio. So also we can think about using the ratio to solve this kind of question. So here, we can first calculate the speed of the ratio. So the speed ratio of A to B, it is what? So first, VA to VB here, right? It is based on the same time. They both travel from P and Q to C. They are from the same time, right? So VA to VB is just the PC to CQ, and we know PC here is 1600, right? So it is 1600 to CQ. And then after it, right, after the meeting, the A speed get decreased by half, right? Decreased by half. So it will become 1600 divided by 2 to CQ, right? 800 to CQ. So this is the speed ratio. And also, from the meeting point until A come back to C again and B go to P again, this is also the same time, right? So we can list the distance ratio here. So A here traveled 2 times CQ. And how about B here? B here traveled 1600, the whole CP here, right? So it is 2CQ to 1600. It is also the same ratio to after the VA to VB, right? We use the prime here. So it is 800 to CQ. So you can just build the equation, right? 2CQ squared is 1600 times 800. So this one we know is 2 times 800, right? 2 go away. So CQ here will become 800 meters. So the answer here is just PC plus CQ. So it is 800 plus 1600 will give you 2400 meters. Right, it is 2400. Okay, now for the last question. So we have 2025 ladies, and each one is either an angel or a demon. And yes, they make the following statements. So here, the first lady said exactly one angel among this. So it is meaning that we have one angel and 2025 minus 1, 2024 demons. How about the second lady? Yes, 2 demons and angels 2023. The third, 3 angels, 2022 demons. The fourth, 4 demons, so 2021 angels. So how about blah 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 until we get 2023 lady. The 2023 lady said, I assume we have 2023 angels and 2 demons. The last one said 2024 demons and 1 angel. So based on it, can you find the circumstances they have just assumed for? They have just assumed. So yes, the first one and the last one, they are giving you the same assumption, right? The second one and the 2023rd, also the same assumption. How about the third one? The third one will also give you the same assumption, right? But here, the situation can only be one, right? There are only one correct situation here. So it means among the 2024, among the 2024 assumptions, only 2 of them will give you the right situation. So we know the 2024 ladies, only 2 of them are telling you the truth. And demons sometimes lie, sometimes tell the truth. And it's asking at most the angels. So here, we just make the demons being the minimum, right? So here, the maximum for the angels here is 2. And how about the 2025, the last lady here? So she said, you are so boring. So do we know she is telling the truth or not? We don't know. Because we don't know whether the ladies are boring or not. So let's just assume she's telling the truth. These kind of ladies are so boring. So we have a maximum of 1 lady here. So we know the total maximum. It's just the 2 parts maximum adding up, right? 2 plus 1 will give you 3 angels at most. So here we have at most 3 angels existing here. Alright, so this is the end of our TASMO sample paper 4. Right, this is the end of our TASMO sample paper 4. So do you have any questions here? Okay, if no, then I end our today's live. Okay, so see you guys later. Yeah, I will end today. This is the end of our today's live. Yeah, thank you very much.